Falcon 9 soars again. SpaceX pushes reusability limits with back-to-back launch Milestone. In a bold demonstration of innovation, reliability, and cost-effective launch engineering, SpaceX once again rewrote the rules of modern spaceflight on May 13, 2025, by successfully launching a Falcon 9 rocket carrying 28 Starlink satellites into low Earth orbit. The mission, which lifted off at 6:55 a.m. Eastern Time from Space Launch Complex 40, SLC-40, at Cape Canaveral Space Force Station in Florida, did more than simply expand SpaceX's Starlink internet constellation. It pushed the boundaries of orbital-class rocket reusability to unprecedented heights. The first stage booster used for this mission, designated B-1062, flew its record-breaking 28th mission, making history as the most flown orbital booster in the world and setting a new industry benchmark for reusability that no other commercial, governmental, or private aerospace entity has come close to matching. The launch began with the familiar, thunderous roar of 9 Merlin 1D engines igniting in unison, sending a column of flame and smoke into the Florida morning sky. As the rocket climbed skyward, it passed through Max Q, the point of maximum aerodynamic pressure, with ease continuing the flawless ascent that has become synonymous with SpaceX's operational cadence. Just over 2 minutes into flight, the first stage shut down and separated from the second stage, beginning its descent back to Earth. Moments later, the second stage's single Merlin vacuum engine ignited, carrying the 28 Starlink satellites toward their final orbit. Meanwhile, back on Earth, the first stage performed a series of 3 precise burns, culminating in a controlled descent and successful landing on the autonomous drone ship A Shortfall of Gravitas, stationed in the Atlantic Ocean. This marked the 28th recovery of B-1062 and one of more than 280 booster recoveries in total for SpaceX, a testament to the company's unrivaled expertise in vertical landing and reuse. For all the precision and excitement of the launch itself, the star of the show was undoubtedly B-1062. First launched in November 2020 on a mission for the United States Space Force to deliver the GPS-3 SV-04 satellite, the booster has since supported an eclectic range of missions. From national security payloads and high-profile crewed missions like Inspiration 4 and Axiom Mission 1, to the deployment of communications satellites, rideshare payloads, and dozens of Starlink batches, B-1062's service record reads like a history of modern spaceflight in miniature. It has launched from both Kennedy Space Center and Cape Canaveral, undergone repeated inspections, minor refurbishments, and real-world stress testing, all while continuously proving its reliability, adaptability, and endurance. SpaceX originally stated that each Falcon 9 booster was engineered for up to 10 flights. That threshold was surpassed years ago. Now, with B-1062's 28th successful flight, SpaceX has not only doubled but nearly tripled the original flight target, showcasing the fruits of continual engineering iteration, materials testing, and flight experience. The booster has become an enduring symbol of the company's larger strategy: to reduce the cost of access to space not by incrementally improving expendable technology, but by fundamentally altering the economic model through reusability. According to CEO Elon Musk, this is only the beginning. He has openly stated that Falcon 9 boosters may soon be certified for 40 or more flights, thanks to upgrades in avionics, heat shielding, and refurbishment protocols. While B-1062's record-setting performance made headlines, the mission's payload was no less significant. The 28 Starlink satellites on board were part of Group 6 to 65, another installment in the deployment of SpaceX's second-generation, V2 Mini, Starlink satellites. These newer models are designed with improved capabilities, including higher bandwidth, increased beamforming precision, and, perhaps most importantly, inter-satellite laser links that allow data to be routed in space without relying on ground stations. This leap in functionality dramatically enhances the latency and performance of Starlink's global internet service, which now spans more than 70 countries and serves millions of users in urban, rural, maritime, and aviation sectors. For remote areas lacking conventional broadband infrastructure, Starlink is proving to be nothing short of revolutionary. The continued deployment of Starlink is only possible because of SpaceX's aggressive launch cadence and technological infrastructure, particularly the ability to reuse boosters like B-1062 over and over again. So far in 2025 alone, SpaceX has already conducted over 50 launches, averaging more than one launch every 3 days. The May 13th mission came on the heels of another Falcon 9 launch just days earlier from Vandenberg Space Force Base in California, part of a back-to-back cadence that highlights the company's operational maturity and logistical strength. Unlike traditional aerospace operations that require months of turnaround time and static scheduling, SpaceX operates in a near-continuous launch environment, resembling the rhythm and scalability of a high-tech factory rather than a conventional space agency. From a strategic standpoint, the implications of the May 13th launch are multifaceted. First, SpaceX continues to outpace its competitors, both legacy aerospace firms and emerging startups, in terms of cost per kilogram, launch frequency, and reusability. Second, the company's vertically integrated approach, manufacturing rockets, satellites, ground terminals, and managing the launch system, allows for efficiencies and iterative upgrades that others cannot easily replicate. Third, and perhaps most importantly, each successful launch and reuse further normalizes the idea of routine access to orbit, a key pillar in Elon Musk's broader vision of making humanity a multiplanetary species. Beyond Earth orbit, SpaceX is also preparing for the advent of Starship, its next-generation fully reusable Super Heavy launch system. But while Starship remains in testing, Falcon 9 continues to perform the heavy lifting, launching everything from Starlink satellites to NASA cargo missions to the International Space Station. The lessons learned from 28 flights of B-1062 are informing the development and operational expectations of Starship, which, like Falcon 9, will aim to launch, land, and relaunch with minimal human intervention and turnaround time. The symbolic resonance of this mission cannot be overstated. In the early days of rocketry, boosters were disposable, falling into oceans or burning up in the atmosphere after a single use. Each mission cost hundreds of millions of dollars and required years of preparation. With Falcon 9, and specifically with boosters like B-1062, SpaceX has turned that paradigm upside down. Today, rockets can fly dozens of times, land themselves with astonishing precision, and be readied for launch again within weeks. They are no longer artifacts of monumental endeavor, but working machines, durable, repeatable, and increasingly indispensable. In the broader narrative of space exploration, May 13, 2025, may not go down as the day we return to the moon or set foot on Mars, but it will be remembered as a critical stepping stone. It's a day when the dream of industrialized, affordable, and scalable spaceflight came one step closer to reality. It proved that reusability is not just an engineering challenge, but a transformative business model, one that will define the future of everything from satellite communications to interplanetary transport. Looking ahead, B-1062 is expected to fly again, likely within weeks, if inspections find it flight-ready. If successful, its 29th mission could further widen the gap between SpaceX and every other launch provider on Earth. As the company continues to push boundaries, each launch becomes more than just a technical feat. It becomes a chapter in the unfolding story of humanity's ascent into the stars. For now, Falcon 9 remains the world's most reliable and most frequently flown launch vehicle. And with B-1062's historic 28th flight behind it, the rocket has more than proven that the future of spaceflight is not disposable. It's repeatable, reliable, and rapidly evolving.